All right, hello everyone. We'll go ahead and get started here. Thanks for joining. I have the chat open here and we'll check it periodically. But for anyone, if this is your first time, my name is Daniel Mangum. I'm a software engineer at Upbound, and this is TBS. So basically what we do on this show is go through different cross-plane topics, different Kubernetes topics, and kind of trying to illustrate some of the concepts we're introducing with the project, and also just give general updates on what's going on. So today, and I can go ahead and move over to the stream setting here, so you don't have to look at my whole face for the whole screen. But today we're going to look at a new kind of sub-project of Crossplane called Crossplane-Runtime. And we'll look at kind of the history of this project, why we decided to break it out into its own sub-project, and then, as promised on Twitter, we will go ahead and build something with it. So we'll show kind of how it integrates with KubeBuilder and controller-runtime and some of the Kubernetes frameworks to be able to build some pretty cool stuff. So I'll go ahead and look at the chat here and see if we have any messages. So it looks like we have Jared, Bassam, and Phil, all Upbounders here. Glad to have you. Thanks for tuning in. Looks like in total, we've got about 10 people on here. So if you haven't introduced yourself, feel free to go ahead and do so. I am not going to keep the chat open the whole time, but I will check it every 5 to 10 minutes just to make sure that I don't miss any questions or anything like that. And if anything comes up along the way, please feel free to bring it up. So let's go ahead and get started. So the history of Crossplane-Runtime is that it used to be part of our core Crossplane project here, and it was basically the plumbing and things that were shared across the entire code base. And if you haven't been kind of keeping up with our direction here, we're breaking out different providers like GCP, Azure, AWS, etc. Into their own stacks, which can be installed into core Crossplane. And with that, there is kind of a library of shared features that can be implemented in all stacks and kind of help you write reconcilers and that sort of thing to manage external resources. And because that would be used in core Crossplane along with the individual stacks themselves, we wanted to break that out into its own project here, Crossplane-Runtime, so that it could be versioned separately and various stacks and core Crossplane could take dependencies on it and use different versions if necessary. So this is pretty in line with how Kubernetes does things as well. So you may be familiar with controller-runtime, which is basically a Kubernetes project to help you build controllers, and we use it within Crossplane. And Crossplane-Runtime fits actually very well into this. So what I like to say is the controller-runtime makes it a lot easier to build Kubernetes controllers. Crossplane-Runtime allows you to build reconcilers for those controllers in a simple manner, in a consistent manner, specifically for external resources. So if we look at KubeBuilder, which is a framework for kind of generating Kubernetes projects and extensions, you'll see that they actually use Crossplane-Runtime inside of here. And if we can find an architecture document here, then we can see a little bit what that looks like. So let's look at this simplified scaffolding document. And you'll kind of see the structure here. And here we import the controller runtime, and it has this new controller manage by pattern, which allows us to basically very simply add a new controller to a manager, and then add our reconciler to perform the actions for that controller. So if we look into core Crossplane, we'll see that we're using this actual exact pattern. And we've kind of adapted the KubeBuilder framework a little bit to build on top of this, but it is very similar. So let's look at AWS, and we'll look at, let's see, Elasticache here. And what you'll see is we're importing that controller runtime just as KubeBuilder does. And we are adding it to the controller with this controller runtime new controller managed by pattern. And so basically what you do is you create your reconciler and you pass that into this new controller managed by, and it says, I will set up all of the controller stuff around this and add it to the manager and make sure it's talking to the Kubernetes API server. And you just have to provide the reconciling logic, which is pretty simple if you have a very simple reconciler. However, reconcilers get a little more complicated when you're dealing with external resources. So what we've done with controller runtime, and this is a big thanks especially to Nick and Muvafiq, who are two of the core contributors here to Crossplane, is implement these shared reconcilers. So what you'll see here is instead of creating a new reconciler object, we have this new managed reconciler, which is going to return a reconciler based on the arguments we give it. And this is importing the Crossplane-Runtime library that I mentioned earlier, but it used to just be part of the core Crossplane here. So let's go back and look at what's actually in Crossplane-Runtime. And I'll take a minute to check the chat here, see if there's anything new. Doesn't look like it. So if we look in Crossplane-Runtime, there's a number of things that are important here, particularly this resource package here. So inside of it, you'll see a number of different kind of shared reconciler type things. We have a claim reconciler, a manage reconciler, and then default class is also a form of reconciler as well. And what we were just looking at for AWS Elasticache was usage of this shared managed reconciler. So basically this provides an interface for implementing a reconciler, a managed reconciler, which is simply what we define as a reconciler that manages an external resource. So for instance, an AWS Elasticache instance would be one. And basically what we're saying is there's these four things that you want to do when you're managing an external resource. You want to observe it, so basically see what the state is of the external resource and compare that to the desired spec that you've defined on your object. And then based on that observation, you want to either create the object if it doesn't already exist, update it if its state has drifted from that you defined in the spec, or delete it if you've decided to delete. Another thing that I would mention here is it would be a good idea to go ahead and kind of plug our Slack group here. And let me pull it up real quickly. So crossplane.slack.com. If you want to go and join here, we have a link on the README, and it'll be useful to, here's our link. It would be useful to join this group because we're going to be using this TBS channel here to demonstrate some of the functionality. So if you want to go ahead and join this group, that'd be great, and you can also get plugged in with the community and ask some questions here. But back to controller runtime, Crossplane runtime. So you see that interface, and we'll actually look at the reconciler that's returned to us, and this is where we're creating the new managed reconciler. We're passing in the kind of object we want to watch. We're passing in the manager, and looks like Peter here says hi YouTube. So we're glad that you're watching. So back to the runtime. So here's the reconcile loop. So essentially what we're doing is we're getting the managed object. So this is the object that you've created in Crossplane or in Kubernetes. It's a Kubernetes object. And you're going to connect to it, and then you're going to observe it. So whatever function you pass in for your observe, that's what's going to be used to essentially determine what we need to do to the object. So you'll see here that if the object itself was deleted, then if the resource exists, so depending on the observation we make, then we may want to delete the external resource. So you'll see here where we call external delete. If we need to publish any information about secrets that we got from the external resource, then we'll do that here. If the resource does not exist, then we want to create it. So you'll see we call the create function that's passed in. And then if we need to update it, we'll call the update function. So let's look at what this looks like for Elasticache again. And I'm using Elasticache because it's been ported over to this manage reconciler pattern, which has actually done a lot to help us standardize on a controller pattern, which has been really helpful just for consistency and implementing new types into the API. So let's look at the Elasticache controller again. And it might be useful just to go ahead and open this up in my IDE here, but we'll see in a minute. So if we look here, here's the connector function. So this is how we connect and actually access the resource using a provider and a secret, which we'll see here in a little bit when we actually implement our own instance of a manage reconciler for Slack, where we're actually going to post messages to the Slack channel, and we'll connect to it via a provider in that way as well. And then here's our observe function. So basically what we're doing is we're getting a resource managed type, which basically is just a managed object. So in this case, Elasticache, it could be anything. Later on, we'll see it's going to be a Slack message. And we're casting it to the type that we are supposed to be watching for. So if we get a type that's not what we want, then we want to go ahead and return, this is not a replication group. We're not going to reconcile it. Otherwise, here we're looking to see, does this replication group exist? If not, then we want to return that it does not exist. So resource exists false. And that's going to, as we saw over here, trigger this observation.resource exists. So if it does not exist, then that's going to trigger calling our create function, which we also define here. So once again, checking to see whether the type is a replication group. And if it is, then we want to go ahead and create that replication group and then return any information about publishing that we need to. So it might be a little easier if we just go ahead and jump into what this looks like when actually implementing. Before we do so, I'll check the messages one more time here. And Bassam says to make the font bigger. We can definitely do that. Appreciate the input there. So here in my IDE, I have the TBS repo. So that's also in the Crossplane org here. All right, that was a little too big maybe. All right, this is a little better. So in the Crossplane org, we have TBS. If you want to follow along with anything we're doing here, you can go to the episodes folder. This is episode 1, and then we'll be in the assets directory here. So what I've already gone ahead and done is created a cube builder project here in the assets folder. And that's really simple to get going. If you'd like to do the same, you can go to the Cube Builder book, and it has a very simple introduction. So just to let you know kind of what I did to get started here, if you install the Cube Builder CLI tool, you can go ahead and init a project. And then I've created a number of kinds here in a Slack API group. So if we look here, let's see if I can make this bigger as well. Yeah, there we go. We'll have the V1 API, and you'll see I have 2 types here, a provider and then a message type. And what KubeBuilder will do is it will generate deep copy functions for that, and it will also generate CRDs for us. So you'll see some of this in the make file. essentially what it's doing is going through this controller gem, which uses controller tools, which is another Kubernetes project, and it's taking the types defined here in our API folder, and it's generating CRDs in this bases folder here. So an easy way to get started developing locally is using Kind. If you're not familiar with Kind, it's basically just a local development tool for Kubernetes to get a cluster running very quickly. It's recommended as a way to kind of test with KubeBuilder, but you can use any Kubernetes, managed, provided Kubernetes cluster or Minikube or anything like that to do the same. We will be using Kind today, but basically, what we've done here is created a provider type. So this is very common in Crossplane, where a provider basically represents a connection to a given API or managed resource provider or something like that. So we have a provider for each of our cloud providers. We have a provider object. So if I go back over to the Crossplane repo here, and if you actually want to see an implementation of this, you'll see in our examples folder, we have providers for each of AWS, Azure, and GCP. And if we look into this, essentially what we're doing is we're creating our secret, which encodes our AWS provider, GCP provider, or Azure provider credentials, and then we're creating a provider object which is in that provider's, that managed resource provider's API group, which essentially just references the secret. And then whenever we want to make a call using the Go client in our manager for our controller, then we'll just use this information encoded into the secret. And we're going to do that with Slack here actually in just a moment. So we'll start to see actually usage of the controller runtime here, the Crossplane-Runtime, excuse me. With anything with this runtime v1 alpha 1, that is actually importing our Crossplane-Runtime here, you can see. And besides just the managed reconcilers and that sort of thing, we also have these embeddable types. So we're saying that any resource spec we create is going to want to have these type of fields in it. So if we look over in Crossplane-Runtime, then we'll see in the APIs group, we're not actually generating any CRDs here, but we are creating a number of embeddable types. So let's look at resource.go. I believe that's where the resource spec is. So essentially what this does is in the resource claim spec, we're saying these are things that we want on every resource claim, and this kind of allows you to be compatible with Crossplane. And you can just embed this into your resource claim spec. Or in this case, we're using a resource spec, so you can just embed this without having to worry about including all of these things here. You can embed this and you'll know that you'll be compliant with Crossplane. So it just makes it a lot easier to get started with generating your CRDs. So we do that here. As I said, this is a Slack message. It's a representation of a Slack message in a Kubernetes object. So we're going to basically down the line, we can look here, and we will create a message in the TBS channel in our Crossplane Slack using YAML configuration. So what you always wanted to do, send a message in Slack via YAML. It's obviously much easier than just typing it in, but it is useful for showing a demonstration here. So what we have here is essentially the channel that we want to send it to, the text we want included in it, and then anything that's part of the resource spec that Crossplane says we want this present. And once again, this is actually not a stack that's getting installed into Crossplane. So this Crossplane-Runtime is really useful outside of just providing Crossplane stacks and that sort of thing. You could use it in any project to extend Kubernetes to kind of build in our same pattern. Especially with external resources, it's useful. So in this case, our external resource is the Slack message. We'll also see this message status, and basically what it has here is a sent field, which is just a Boolean that says, was this message sent? This is not necessarily the best way to keep track of a message's status, and we may implement a better way in the future of this episode. But essentially what I'm doing is, you'll see in the controller in a moment, that the sent bool just gets set to true after it's sent, and that will allow us to recognize that the object has already been created in this case. You also see we embed the resource status here, and then the message includes both the spec and status. So when we run, and we have this helpful make file here that KubeBuilder provides, when we run make manifest, what it's going to do is generate these CRDs in this CRD basis folder here. So we've already done that, but I'll go ahead and show. Let's see if it works here for us, and I'll go ahead and make this larger as well. Maybe a little bit more. All right, make manifest, I believe. Yep, so you'll see it's running that. We shouldn't see any changes here because it's already generated, and we did not make any changes to the message type or the provider type, which are the only kinds we're defining. But let's say we added let's add another field here. And let's just call it dummy. So this is just going to be to demonstrate how KubeBuilder goes about building these CRDs. So we had a minor change here. So what we're going to need to do is update our deep copy functions, which this KubeBuilder project also gives us an avenue to do via make generate, and then we will recreate the CRD as well. All right, so first let's make generate, and that actually didn't change anything because it's just part of the spec. Oops. And now we'll make manifest. And we should see a change here. And we do, in fact. We see a change to the messages object. And if we look at where that is, you'll see that this dummy field has been added. So we actually don't want that there, so I'm going to go ahead and remove that. And we can make manifest again to go ahead and update that. All right, so now that we have our CRDs defined, let's look at the controllers. So we don't need a controller for provider because we actually don't take any action when it's created. It's basically just stored in the Kubernetes key value store, which is etcd. So we don't need to watch for that or take any action when one is created or deleted or anything like that. We'll simply use it with other controllers to look up our connection details to Slack, and I'll show how to do that in a moment. But for our message, we do want to take action when one is created. We want to post that message to Slack. So you'll see here that we have the message controller, and you'll see a common pattern. So here we're using the Kubernetes controller-runtime to add a controller to the manager, and we're watching for this Slack message type that's defined in the APIs directory. We're naming the controller, and we are also using the Crossplane-Runtime to create a manage reconciler for this kind. So we know that we're watching for the Slack message kind with this reconciler, and then we're going to provide the functions via this connector. And you'll see we're passing our Kubernetes client in to the connector so that we can utilize that to find objects in our Kubernetes cluster. So the first thing the connector does is it supplies a new client function. So this is usually dependent on the cloud provider that you're using or any other managed service provider. In this case, it's Slack. So basically what we're saying is this is how you generate a new client to talk to whatever API we're going to need to take actions on an external resource. So you'll see here that we're calling this clients.newClient function. And when we do so, we're passing in this secret key here. So I think it'll be useful to look at this provider .yaml that we've created here. So what we're doing when we get started is we'll create a secret which has my Slack access token in it. It's going to be base64 encoded in this secret, and it's in this token.txt file, which I will not show you here. And if you just replace token.txt with your own Slack token after cloning this repo, then you can do the same thing here. And then we have this provider, which is basically just a Slack provider which references the secret, which we're going to use to get the token out of the secret. And the way we get the token in is when I create this, I'll just run this provider script, which basically is base64 encoding my Slack token, replacing that base64 encoded token variable in the provider.yaml file here and storing it in a Kubernetes secret. All right, so looking back at the controller, what we're going to do when we connect is we're going to make sure it's a Slack message that we're seeing an action on. And then we're going to get that Slack provider, which needs to go ahead and exist. And if it doesn't, we'll say we can't get it. So we're using the Kubernetes client to get that instance of the Slack provider. And you'll see on the actual message that will reference that provider. So we're saying we want the provider example in namespace default. So this is going to use that information to look up that provider object that we've created. And then we want to use the reference to the secret on the provider, which once again, we can look over and see that we're referencing this example provider Slack secret, and we want the token out of the data section of that secret. And so we're going to get that secret, and then we're going to get the token out right here, and we're passing that to our new client function. So I said the new client function is this clients.newClient. And this is a common pattern you'll see in Crossplane, where we have a kind of separate client that we inject for the cloud provider. And we're increasingly standardizing on basically just providing a function to create the client and return it of the client of the managed provider. And then we'll just call the functions for create, update, delete directly on that client that's returned. So essentially what we're doing here is taking the credentials that we got from the secret, we're passing it into slack.new. This library, which is very helpful here, I want to give this person a shout out actually. Let's see if we can find it here. It's always nice to give people a shout out when you build on top of their work. So this is a really helpful library just for interacting very simply with the Slack API. So Norberto Lopez, I believe, thank you for the work you do on this, and we're going to utilize it today. So we really appreciate your effort. But essentially all you have to do is pass in your access token, and it's going to return a client. So how this looks here in the message controller is after we connect and get the client, then we're going to be able to use it in our external object, which provides our observe, create, update, delete functions. And we'll have this client embedded in it. So in our create function, we can just call client.postMessage, and we already have access to the client with authentication and everything like that. And if we look over into the resource manager in the Crossplane-Runtime, we've really got to stop confusing Crossplane-Runtime and controller-runtime. They're very similar. So if we look over back in the manage reconciler again, we're going to see that connect gets called where we create that new client for the managed service provider. Let's see here. So we create the new manage reconciler, and yeah, we'll see this external connect, right? And then the external observe. The external is what's returned from our connect message. So this type here, we're returning it with our Slack client embedded, and then we're able to call the external.observe, create, update, delete functions from that. So that's kind of how the plumbing works there. And so yeah, let's look into what actually happens with our Slack message here. And I'll take a moment here to look at the messages and see if there's anything. Marcus, I appreciate your YAML and YAML jokes. Looks like we don't have anything pressing here. If anyone has any questions, of course, feel free to ask them. I know how much we all love YAML. So in our create function, we are going to, well, first, excuse me, in our observe function, we're going to check if that status field is set to true. The sent field is set to true, excuse me. If it's not, then we're going to want to return an external observation of resource exists false, which is going to tell our managed reconciler that we need to create it, which will result in calling this function, which is going to set the status on the object that we're creating it, and then we're going to actually post that message within the channel with the text that we provided. So that's how the kind of configuration on the YAML actually gets to working. So we also have these update and delete functions, which here are not really doing anything. We can, and we may implement depending on how much time we have. We could say, something like, let's look at this message and see if anyone has, responded to it or something like that, and then act accordingly. Or we could remove this message or something like that. It just depends on sort of what this Slack client makes available. But I'm going to go ahead and walk through how we can get this set up. So as I mentioned, we're going to want to use kind to create a local Kubernetes cluster. So that might take a minute to get going here. While that's working, let's look at the actual kind of binary that runs here. We're actually not going to compile it. We're just going to run it locally. But this is the actual file that's the entry point for our controller manager here. And this is all generated from KubeBuilder, which is really nice. And you can kind of just adapt it to how you see fit. So you can see I've actually kind of adapted this here with our own controller pattern that we use in Crossplane. But essentially it's just creating a new controller manager, which is going to talk to the API server and listen for events. And it listens for anything on things we add to the scheme. And you'll see that we do that up here in our APIs. Let's see here. Yep, that we're registering these types with our schema here for our controller manager. And then we are going to register our controller manager, or our message controller, excuse me, with our controller manager so that it knows how to act when it does see an event involving a new Slack message. So I had this working earlier, and we'll see if it actually works here. I need to set up my kube config here. Make sure we're using the kind cluster that we've created. So let's just see what pods we have running here. See if we're able to connect. Okay, cool, we're able to. I'm going to create a new window here also. Make this big again. And let's see, no, we do want to be in assets. And this is where we're going to actually run the controller from. And I believe that I don't have Go modules on, which we are using in this project. KubeBuilder uses by default. So we'll need that on to run in here. So we have the cluster up and running. So the first thing that we're going to want to do is install our CRDs. So these were generated, as mentioned, by KubeBuilder in this basis. So what we're going to do is a custom resource definition, which actually just went GA today, I believe. So congrats to everyone on the Kubernetes team for that. Is an actual type inside of Kubernetes, and it basically allows us to create new types. Which is really handy. So what we're going to do here is just pass in this validation schema, which tells the API server, let's see, for instance, that the channel is required and gives a description and make sure it's set and that sort of thing. So to be able to create our types, we need to create custom resource definitions, which are installed across a cluster into our Kubernetes cluster. So we can do that with our handy make file. So you'll see there that we went ahead and used controller-gen to install our Kubernetes custom resource definitions. So it basically just applied everything in that CRD basis directory that we were just looking at. And now we are able to actually create instances of the provider and message types. So we can also run make run here. And this will get our controller running just locally. And you'll see our log messages here, hopefully momentarily. Yeah, so it's going to run main.go, and you'll see it setting up the controller for the different types here. Looks like, oh, we need to set up the this kube config here in this other terminal session as well. So let me grab that. I'll watch my copy paste struggles. So now we've got our kube config set up, which basically tells it, talk to the Kubernetes cluster that Kind created. So Kind is a great tool. I definitely recommend for local testing. And we'll see here that it will successfully set up the controller this time. Although, now that I said it, it probably won't, but it did. So we'll see here that it's just emitting some simple logs. So I'm going to make this a little bit smaller. Oops, excuse me. So you'll see that it's setting up the metrics server. It's starting the event source for the message kind. And then it's starting our controller for the message as well. So let's go ahead and create our provider. So as I said earlier, our provider is going to create a secret with our token encoded in it, which is in this token.txt file. And it's going to replace this base64 encoded token with our actual base64 encoded Slack token. And then we're going to create this provider object, which we shouldn't see any logs about in our controller because we don't have our controller manager because we don't have a controller watching it. So let's see, that's in the config, TBS, let's see, Slack. You also see I have this GitHub folder here, which we might get to adding some CRDs for creating GitHub repos and that sort of thing later on if we have time. But I will go ahead and create the provider. And because we installed this provider Slack kind here, it's going to be able to create an instance of it. So let's see here. You'll see it created the secret and the provider, and we shouldn't see any logs about it over here. But now we can create our message. So when we create this message, what it should do is watch for it, and if successful, it will post this text into this channel. So I'm not sure if that's the channel we actually want here. Let's look over. And Jared said, does Kind work on Mac too? I'm actually not entirely sure about that, but I'm sure we could look it up. I believe it does. I don't think, well, I thought that Google would know that I want the Kubernetes Kind here. Yeah, I believe anywhere you have a Docker client running, it's going to work on Mac, which is really nice. Because essentially what it's doing is installing Kubernetes. It's running Kubernetes in a Docker container, which can get a little bit confusing. It's kind of like Inception, that you're able to run containers with Kubernetes, but Kubernetes is running in Docker. And it looks like Javad actually answered that for us, so thanks, Javad. So let's hop back over to our TBS Slack here. So like I said, if you haven't joined, yes, Jared, you can eat Kind bars while it's working. And And I mean, thanks for Googling it. Yeah, that's my primary function here is professional Googler. So glad to be of service. And so in our TBS channel here, we'll see that this is our Slack channel ID. I don't remember if that's the one that I left in here. So if it's not, we'll update it. It looks like it is not. So we want to post into the Slack channel ID, and this token that I'm using is actually generated for the Crossplane Slack. So that's how it knows what workspace to operate in. So let's make sure we have everything right here. We're referencing the provider correctly. We want this text and this channel. So let's see if it works. I've had some trouble with the Slack API locking me out for rate limiting, but it seemed to be working this morning, and I actually have, for anyone who's using this after this episode, I have these token test folders, which are basically just allow you to plug in your token and test that it's working, and that allows you to kind of identify if you're running into rate limiting or other. So let's go ahead and create this message, and we'll see if it posts into the Slack channel. So it looks like it reconciled it, and it looks like we're having issues with posting. So let's investigate what's going on here. We can describe this, and we should see invalid auth. All right, so what I'm going to do here is I'm going to delete this, and I'm going to quickly check to see if my token is valid here. And I will do that under the guise of another screen here so that no one gets access to my Slack API token. So, all right. Apologies for the delay here. And I'm going to take this down here for just a moment and update my token. Well, it looks like the token is working, so I'm actually going to try my token test here. Hello, Marcus. And our token test basically just gets a user information. So I'm going to run this here. It wouldn't be a demo unless we ran into some errors here. So let's see if we can so it looks like that we are able to use my token to get some information about me here in the Slack channel. See if we're getting more. Looks like we're having a bit of a delay here, so sorry about that. Let me see if we can try this again here. All right, so we got invalid auth. Once again, checking my token here and my provider script. All right. So we're going to try this again here. But it is nice that we automatically, our manage reconciler tells us the error that we're getting from the Slack API. So that's pretty handy. So let's look. I'm going to remove this. Slack. And I'm going to delete that provider that we created. And hopefully, when we run this again, it's going to work out for us. All right. What I can do also is appreciate the message, Peter. I will generate a new token here and see if we can get that to work. All right. So all I'm doing behind the scenes here is kind of updating this token.txt file here, and we'll give it a try. Okay, so once again we'll run provider and we'll make sure, and then we will, let's look over here again. So yeah, the last thing it did was delete. You'll sometimes get this benign error from Kubernetes, which basically says that the object version is out of sync, but that is not anything related to this, and actually can be ignored. I think there's a few issues actually on the controller runtime about that. So let's see if this message will work this time. So we will, there we go. We did, in fact, get it to work. So you'll see our hello from TBS live. And we were able to post, so I'm going to stop the manager. And yeah, so that was an example of, and let me pull this up again, of being able to create an external resource. So once again, what you'd want to do in the future, and we are running a little low on time here, but is in something like this message controller, you want to implement update and delete. So this is very simple for posting a message, but as I mentioned earlier, you may want to act based on if someone has posted or reacted to the message, or you may want to do something on delete. So it'll see, if you delete the object from your Kubernetes cluster, if you want it to also delete from the managed service provider or something like that. And quickly before we wrap up here, looks like we got some, thank you, Jared. Appreciate all the reactions here. We have some great Slack emojis in our workspace, so if that's not reason to join, then I don't know what is. But I wanted to quickly look at some of how the update and delete work in other types here. That's not what we want. So once again, looking at this AWS one, we can see how it handles updates and that sort of thing. So it has a very similar connect function here, pretty similar observe. It does a little more interesting stuff. decently similar create, a little more complex again. Update, basically what we're doing is getting the Elasticache group and making sure it matches what we want it to. And then we're running this replication group needs update, which is a function in our client, which basically just compares the things we get back from the AWS API to our Kubernetes object and lets us know if we need to do it. And if so, we can return an error that it was unable to modify it if it's unable to, or we can actually do the modification and not return an error and just say we had successful update and continue reconciling from there. On deletion of our Kubernetes object for an actual managed resource like Elasticache, we want to actually go ahead and delete the replication group and clean up kind of what we've done on the managed service provider, and that will mirror our deletion of our object in Kubernetes. Looks like we have a few more messages here. Oh, okay. So yes, with the auth token, the magic I was doing behind the scenes there is essentially you can get very simple legacy tokens with Slack, which is what I'm using just because it's the easiest way to interact with the API. If you're actually building an app or something, you'll want to register the app and get OAuth tokens and that sort of thing. But it appears that the token was expired. And so I just reissued a new token and then plugged that into the token.txt and then ran provider again, base64 encoded that, etc. So that was the issue. But I think it's really important to illustrate that this ability, which just basically we have because we embedded the resource status into our message here. So we can look at that again. And we're adhering to this managed resource interface, which is the kind that's actually passed into our controller here. So if we look back at our controller, we're taking this resource.managed interface, which basically is saying that it has these sort of that we can't really see it here because of the way we do it in Crossplane-Runtime, but it basically has these methods that are defined as these sub-interfaces of the managed interface. And if we look back at the message type, here's where we implement all of these methods, which allows it to do things like, write the connection secret. It allows it to set the binding phase, etc. And then we also have things that the resource status provides, like condition status, binding status, etc., which then allows us to specify conditions and that sort of thing, and put this message on it that we got back from the Slack API. So that's really helpful. And if we described it after, it might say successful reconciliation, and we can get all manner of methods back here by just returning what the Slack provider in this instance tells us, and we also append our own message here, which is what that errors.wrap does. So if we look back at the message controller, what we were getting that error from is right here. We're returning the error from the actual Slack client here, as well as our error message create. So we're saying in general that we are unable to create the message, and then we're saying, this is why invalid auth was the response we got back from the Slack client. So it looks like we're getting towards the end here. I will once again check the messages quickly. See if we have anything here. Yeah, I checked for the new line in the token file. I don't think that was it, but I also actually just I deleted everything and repasted the token, so that could have actually been it. So that's a good point. But last thing we wanted to do here is wrap up by talking about kind of what's coming up with Crossplane. So as always, you can go into our issues here And if you look at our epics label, is what I always like to do to get kind of a high level overview of what's going on. You can see these are the things that are all in the 0.3 milestone, which you can also look at that directly to see. And so you can see that we are moving these cloud providers out of our core Crossplane project. And if you look in the Crossplane repo, you'll actually see the first one of these appearing in our stack GCP. So basically what we're doing is creating an installable stack that you can install into your Crossplane binary, and will provide all of the GCP functionality and types that are defined. So you don't need to have that if you don't want it. If you're not going to be using GCP, you don't need to install it. So we'll see a similar pattern for AWS and Azure. And that will also bump the API version type to v1 alpha 2. And then we will be removing AWS, Azure GCP API types as well as their controllers from core Crossplane. And we will start all building there, so you can see that happening. If you actually look at the open pull requests, you'll see a couple of PRs related to that. You'll also see that we are going about adding some networking types to the different providers. So we have GCP, Azure, AWS here. And essentially what that's going to allow us to do is, while before if you wanted to deploy something into a virtual network or a subnet or something like that on a cloud provider, you'd need to set that up beforehand or do some scripting to be able to do that by calling the API directly or using some other infrastructure as code tool. Now by having actual network types where we can say, kube control create, VPC on AWS, something like that, then you can reference that in a, let's say a VM or something like that you want to deploy to the VPC. You can control all of that through Crossplane. So we're always adding new types, and this network connectivity is a big effort we have here. And for a little more kind of like forward looking, you can always look in our design document where we define how these kind of things will work. And this is an area that's especially important to get community feedback on. So if you have any thoughts about how this should work, then please feel free to add them. At the bottom here, you'll see that we have the actual types defined and what it will kind of look like to deploy networking types. So here we have a GCP network. If we go down a little farther, we have an AWS VPC and some other networking types here. And then, so what we'll do with WordPress, for example, is we'll create all of these networking types directly. We'll statically provision them. So once we create them, we're actually creating the kind. And then we'll also create classes. So we'll create an RDS instance class and an EKS cluster class, for example, in AWS. And then when we actually install WordPress, those networking types will be available. And but we'll create claims that allow us to dynamically provision the RDS and EKS cluster and database respectively, and that will allow them to be created at kind of provisioning time dynamically. And it also allows for the WordPress installation to be agnostic about the cloud provider behind it. It'll just say I want a MySQL class and a Kubernetes cluster, and I don't care what provider it's on. So if you've set up AWS, then it'll be on AWS. If you set up on GCP or Azure, then it'll be on either one of those platforms, which truly provides portability for applications and that sort of thing. And that actually happens through policies, which we're not going to get into in depth too much, but we should have a blog post coming out about that. A policy essentially just allows you to, and I can show this real quickly actually. A policy allows you to define whatever the default is for a certain claim type. So in strongly typed classes here, we can say create an RDS instance class, for example, then create a MySQL instance policy. And this is saying for all abstract MySQL instance claim requests, we want to default to this RDS instance class, so the actual claimer doesn't have to know exactly what the underlying database type is, but they'll just use the policy. So here in the MySQL instance, they're saying, I want a MySQL database. I don't really care what it is. It needs to be engine version 9.6. And then the default class ref will automatically point it to that RDS instance and provision on AWS. And we'll do the same thing with AKS cluster. So just allowing that portability across cloud providers is definitely a primary mission of Crossplane. And so we're moving closer towards that. And we have a couple of other ideas to expand this as well. So please always feel free to engage with the community, both here in the Crossplane repo with issues or pull requests, or in the Slack group here. So hopefully some of you joined to be able to see what we did today. But we have great conversation here going on, in the general and dev channels, as well as services and stacks, which are a little more focused and allow you to get into conversations there as well. So yeah, I appreciate everyone joining for another episode of The Binding Status. I'll quickly check the comments. It doesn't look like that there's anything new to address. So it's been an honor to host again this week. I'm hoping that we can get a few other people on here as well in the future. I think that Marcus, actually, who you may have seen in the comments, is doing a lot of work on stacks, so it might be useful for him to be able to present some on that as well. But I am glad that everyone came out, and please feel free to reach out in Slack, or you can come to my Twitter handle here and send me a message directly if you have feedback or something like that, or open an issue on the Binding Status repo for a future show topic. So anyway, it's been great to have you, and everyone have a great Thursday.